Hello students, in today's class we will be learning about basic maths. So, this would be your first lecture in the physics stream for your first year, right. So, you know that physics is basically the study of universe around us, the physical world around us. So, the study of that starting from a very small subatomic level to a very large galaxies and even higher than that. So, the study of that is what we call as physics. So, everything that happens around us, why is it happening, how is it happening, the reason behind it. So, that study is what we call as physics. Now, so to be able to do so, to be able to do that study, so we need mathematics, right. So, mathematics is kind of a tool which helps us in understanding or studying physics, right. So, you can understand maths as something which helps us logically. So, that is the logic which drives us during our study. So, any study should have some logic associated with it, right. So, mathematics is the logic which is required for us in physics, right. So, most of the concepts which we would be using in physics you would have already learnt at your school level, but there is one particular subject or chapter which you would not have touched. So, that is what we would study in this first lecture, right, and that part is very, very important in our understanding of physics, right, and it is called as infinitesimal calculus. Infinitesimal calculus, or we just call it as calculus. So, you would understand why this term infinitesimal is being used as we start our discussion, but the topic is calculus, right. So, calculus is that part of mathematics which we would require, right, throughout our 2 years of understanding physics. So, we would be using it in almost each and every chapter. Everything related to physics in one way or the other would be derived or understood using this particular idea. So, it is that important for us to understand physics, clear. So, even in maths you will be learning this later on during your second year. So, for maths you only have 2 chapters of calculus. You have something called as differential calculus and another topic called as integral calculus. But for physics, as I told you, calculus comes in each and every chapter. It is required to understand each and every topic in physics. So, it is that important, and that is the reason why we are starting off with understanding that all the other basic concepts of mathematics required, you will anyway study that in your maths class. So, this is something which you would not study for the next 1 year. So, we can't wait till then, right. So, we are going to get some basic ideas of what calculus is, how we use it in physics and all that, clear. So, as I told you, calculus, so to understand what it is, so you know that basically when I talk about mathematics, so mathematics has different sub categories in it. So, you have something called algebra, so you have trigonometry, you have geometry, and you have probability. So, broadly we can divide mathematics into these parts. You can also say that calculus is another such part. So, we would be using almost all of this everywhere, but as I told you, these 4 concepts are something which you already have a basic idea about. You would have studied algebra, trigonometry, geometry, and probability is not something which we would need as of now. So, all these basic ideas you would have had, so except this, right. So, that is what we are going to learn. So, basically you know that algebra is something where we study about how the parameters are related with each other, how we understand numbers and how the relations between them occur. Trigonometry, you know that it is basically the study of angles and lengths associated in triangle, right. And geometry is basically the study of shapes, sizes, and how something occupies the space around it. So, understanding space, shape, size, so that is basically called as geometry. And probability, you might have had an idea. Probability, as the name itself means, It is something called as chance. So, what are the chances of something to happen, right? So, that is what you basically learn in probability. Now, calculus. So, what you study in calculus is the change, right. So, we can say that calculus is basically the study of change, right. You can say in any parameter, whatever parameter you are studying. So, if you are studying how that parameter is changing, clear. So, that study of how something changes, why it is changing that way. So, that understanding or that idea is what we call as calculus, clear. So, I will tell you why this is very, very important for us. Why do we have to study change? So, especially in physics, we would be studying mostly about how something changes when compared to maths. So, physics, rather than understanding what a particular parameter is, it is very important for us to study how that parameter is changing or how it is going to change, clear. So, I will give you a brief idea of why change is very, very important. Why do we have to study change, right? See, think of a scenario like this. So, you know that earth is basically has a very long lifetime, right. It was formed some 4.5 billion years ago. You know that, you would have heard of it, right. And you know that earth has undergone many changes during its very, very, very long lifetime, right. So, temperature of earth has risen to a very large values, it has dropped to a very small values. So, you would have studied about, you would have known about that, you would have known about ice age, right, where earth was completely surrounded by ice for many, many, many millions of years, right. So, in that way, so the temperature of earth was something which was continuously fluctuating, right, sometimes very high, sometimes very low, and based on that, life on earth was also affected. So, sometimes all the life would have vanished and once again it would have started, only to vanish again, only to, if not vanish, at least decrease. So, it has undergone many, many transitions. Now, think of it something like, think of it in this particular manner. Now, we are living at this present age, right. So, is it important for us to know what the value of temperature of earth was some 10,000 million years ago, or is it very important to us to understand what happens to the temperature of earth in the next 1 year or in the next 10 years, 20 years. So, what is important? So, you all know that understanding of what is going to happen now, right, how the temperature is changing now is what is very important. How it changed earlier is a matter of past. What is going to happen now, how is that change going to happen now is very important. So, that is the basic idea. So, that is why you would have heard of these terms called global warming and things like that, right. So, many scientists are basically worried about earth's fast rising temperatures, right. And so, what is the basic idea behind telling you all this is because change is something which is very, very important. If we humans have to live on earth, we need to understand change, we need to adapt to change, clear. So, that is the most important thing. I will give you a very another example, a very important one which is very relevant to what is happening now at the moment. So, you all would have observed, if you would have watched news or something like that regarding the present ongoing the corona cases which are happening. So, you would observe some graph which keeps coming, which comes most of the time, and you would have seen graphs something like this. Most of you might not have observed, some of you might have observed. So, graphs would be something like this, right. You would have observed graphs like this. So, have you ever wondered what this graph means, or what is that they are showing us? What is it that they are trying to tell us from this graph? Have you ever observed what was on the y axis and what was on the x axis, and did you actually try to understand what type of information we are getting from the graph? So, what does this rise and then reaching a peak and then falling down, what does that imply? So, understanding that is very important. For example, let us say we are at this moment of time now. So, what we have here on the x axis is time, clear, and on y axis It could be many things. Have you ever observed what was on the y-axis, right? Okay, let me tell, let's say this parameter on the y-axis is active number of cases. So, how many people at the moment have that particular virus, right? So, let us say this is how the graph is. Now, think of something, let us say we are at this moment of time, right. So, this is the moment of time. Now, this is the present. We have not yet seen what is going to happen later. So, this is just a model of how generally any virus spreads, right. So, they have scientists have observed how it happened earlier with different viruses, and they are expecting that this virus might also happen in the same manner. So, this is just an understanding, but remember, all of us, or at this moment the world is at this moment of time. So, we do not know what is going to happen here. So, this is all future for us. So, this is all future. No way we can know. No one can travel into the future and see how many cases of virus would be present after some time. But tell me one thing which you think, is it important for us, or which is more important, right? So, let us say this is one time t1 and this is the present time, let us call it as t2. So, looking at how the variation in the graph is at the earlier time, is it of more importance, or how it is changing at this moment of time, or how fast it is changing at this moment of time, is it of more importance? So, what is happening now, how fast is it rising, what might this lead to is more important. You all agree with that, right? So, students, let us try to understand the concept of change by using another idea which we would be generally using in physics, the first topic, kinematics, right. So, let us consider a case like this. So, let us say you are traveling in a car, right, and you are traveling at some speed. So, this car is traveling, right. Okay. Now, let us say you are looking at the speedometer of that car, and the speed shows you 20 meter per second, right. So, 20 meter per second, you know that generally it is in kilometer per hour. So, if I write this in kilometer per hour, 20 into 18 by 5, right. So, it gives you 72 kilometer per hour. Okay, let us say you are traveling at this particular speed. Now, what does it tell us? Does it tell us that your car is going to travel 72 kilometers in 1 hour? Is it what the speedometer tells you? What is the speedometer showing you? What is it telling you? Does it mean it travels 72 kilometer in 1 hour? No, that is not what it means. Okay, you know that this 72 kilometer per hour is something which is valid only for that particular instant, right? Because at the next instant you can travel faster, or you can travel slower, you can put the brakes and you can travel slower, or you can completely come to rest, right? Okay, so now my question is, how do you think the speedometer had calculated this particular speed? See, you all know that speed, the basic formula for speed is distance by time, right? So, this is something which all of you would have studied in your lower classes, right? Now, our basic idea of calculating speed is, so we take a time interval, right, and we observe how much the body has travelled in that time interval, the distance covered by the body in a time interval, and divide that with time interval. Although I have written time here, this is basically time interval, right, the duration between two different instants. Okay. So, that is our idea of calculating speed. Find the distance covered in a period of time, clear, and then distance by time period, right, is what we call as speed. Then, how is the speedometer giving you different values of speed at different times? It is showing you this speed at this instant, right, instant in the sense at this point of time, there is no duration there, correct. So, how is it calculating this 72 kilometer per hour? So, what does this mean actually? So, when the only method I know for calculating speed is between two intervals, how did I arrive at speed for a particular instant? So, how did I jump from this to this? clear. So, that is what we will be learning. So, by the end of this lecture you would be basically having an idea of what this means, what this instantaneous value of speed. So, you would understand what that means, clear, because that is a speed which is valid, which is applicable, which is correct only for that particular moment of time, correct. So, how do we calculate the speed for a moment is what we are going to learn first in this particular lecture, right. So, but before that we have some basic concepts from mathematics, right, which we should be aware of. So, I will give you a brief introduction of those and then we can start off. So, students, the first thing we will be learning about here is called a function. So, you might have heard of it, right. So, function, we can understand that it is basically an operation, right. So, it is something for which when you give an input, it takes that input, it does something to that input, it does some operations with that input and it gives an output, clear. So, it is as simple as that. So, it takes an input, does something with it, it makes some kind, think of it as a machine, clear. So, you give something to that machine, it processes that information and then it gives you an output, right. So, that is what we basically call as a function. So, it takes an input and it gives a single output. Now, single output does not mean that whatever input you give, it is only going to give the same output. So, what I mean is, for a particular value of input you give, it gives you only one output. So, for one input, one output and so on. So, if you have to define what a function is, it is basically it takes an input and gives a single output. Now, so functions can be of different types, clear. So, I can define any kind of function. A function could be algebraic function, it could be trigonometric function, right. It could be logarithmic function. So, it can be of many types. For example, let us consider a very simple algebraic function, which is, let us say y is equal to 2x plus 1. So, if I have a function like this, so whenever you are looking at this, so remember that the basic representation would be like this: x represents the input which we are giving to this operator, right, and this y here is called as the output, and this thing here is basically the function, right. 2x plus 1 is what we call as the function. So, we can also represent it as function of x or f of x. So, this is the function. So, you can look at it like this, right. So, this is the function, right, which is represented as this, clear. So, what this function does is, whatever you put into this as the input, so it takes that input, it multiplies that with 2 and adds 1 to that and gives you the output. So, that is the role of this function. So, function is something which takes a particular information, does some operations to that information and gives you an output. So, in this particular case, you can say if you give 0 as the input, so it gives you 2 into 0 plus 1, which is, this is 2 into 0 plus 1, which is equal to 1, right. Or if you give 1 as the input, it does this, it does 2 into 1 plus 1 and it gives you 3 as the output and so on. So, that is what a function is basically, clear. So, input and output. So, function idea is that. So, there is still a lot you will have to know about functions, but for us in physics that idea is enough. So, because I will be using the term function each and every time. So, you should know what a function is. So, just look at it as some kind of operation, clear, which takes an input and gives an output, right. Okay. Now, So, in this particular case you can see that these are the set of input values. So, whatever I have written here 0, 1, all these are input values, and this 1, 3 and so on what I get here are the output values, clear. So, these are the output values. So, now to give you an idea about what this function is doing, I can write many input values, many output values, and you can look at what is the output for 0, what is the output for 1, what is the output for 2, let us say. So, for 2 that would be 2 into 2 plus 1 which is equal to 5 and so on, right. So, this is one way of giving information of what a function is. So, giving these are the inputs, these are the outputs. So, by that you can get what the function is doing, right. So, there is another way in which we can understand a function, a better way, clear, and this is the way which we will be using quite frequently in physics as well. So, whenever we need to understand something which is very complicated, so this will help us a lot, and that is graph. So, whenever you need to know what a function is doing, clear, you just look at its graph. Now, what is a graph? I will first write the definition of what a graph is or what a graph does, clear. So, graph is basically a pictorial representation of the set of inputs and outputs of a function, clear. So, that is what a graph shows you. A graph is basically a representation of what the inputs and outputs are. So, it is a pictorial representation, right. So, for example, if I draw a graph like this, so let us consider that I have drawn a graph which is like this. Some of you might have known that this is how the graph looks like for a function which is of this form, y is equal to x square. So, if I have a function which is like this, so the graph of that looks something like this, right. So, this is y axis, the output. So, this y axis is the output axis and this x axis here is the input axis. Now, what this graph tells us is that, so do not just look at it as a curve. So, when you look at it as just a curve, it does not tell you much. So, what it basically shows you is that for different values of input given by you, it shows you the value of output that comes out of the function. So, if you substitute this value as the input, it tells you that for this value of input, this is the output that you get, clear. So, there will be many values on the x axis. For different inputs, you will get the corresponding different outputs. So, each and every input and each and every output for that will be represented on this curve. So, if I take some other value, for example, let us say this is 1, you know that if I substitute 1, so if I write input and output values, so if I substitute input as 1, then I get the output as 1 itself. If I substitute x as 2, which is input, I will get 4, 3 I would get 9 and so on, right. So, what we look at on the graph is basically the representation of these sets x comma y, x comma y, x comma y. So, that representation is what we observe on the graph. So, if there is 2 here, so let us say this is 2, the corresponding value which we have on the y axis would be 4. This is 1, this is 2, correct. Similarly, if I take 3 as well, so if I consider 3, the corresponding value which we get on the graph would be 9. So, I have just taken 3 values of input and I have showed you what the corresponding outputs are, but keep in mind graph is something which shows you what the input and output is for every value of input. Substitute any value of input, you know what the corresponding output is, right. So, that is the importance of a graph. So, by just looking at that graph, I can get an idea of what the output does it give for a particular input value, right. So, that is the basic concept of graph. Now, there is another important reason for why we should use graph and how it helps us. So, if you observe here, see, as I change my input value from 1 to 2. So, earlier the input was 1, now the input is 2, clear. As I change my input from 1 to 2, you can see that my output varies from 1 to 4. Similarly, if I change my input from 2 to 3, you can observe that my output is changing from 4 to 9, correct. So, if I just show that here, if I just draw a horizontal line here as well as here. Now, observe closely. So, as my input changes by 1, so this is the 1, so this width here will be 1, right. My output is changing from 1 to 4, which means 3, clear. So, this length is 1 and this length is 3. So, this length is the change in output, clear. Similarly, from 2, if I change my input by 1 again, so if this value is 1 again, how much is my output changing? So, from 4 my output is changing to 9, which means here the value is 5, this value will be 5. So, now if I ask you a question like this, I have told you that we will be mostly discussing about change, right. If I ask you something like this, so where is the output changing faster? Where is the output changing faster due to changes in input? So, if you are making some changes in the input, right. So, when you are changing the input values from a particular value to some other value. So, where is the output changing faster, or where is there a large change in the output? I will ask you, is it at x is equal to 1 or is it at x is equal to 2? What can you tell from the graph, right. So, you can say that from 1, if I increase it by 1, output is increasing by 3, right. From 2, if I increase the input by 1, the output is increasing by 5. So, where is there a large change in the output for the same change in input, right? It is at 2. So, at 2, we can say that the output is changing faster when compared to the change happening at 1, clear. So, why is it that way, right? How can we understand that it is changing faster at 2 and not so fast at 1? By looking at the graph is what we will be learning. So, a graph, as of now you do not know, right. So, once we discuss the next concept, you will understand what is that parameter which decides how fast the output is changing. So, by looking at this graph, if I draw the same graph again after the next concept, you will immediately be able to tell why is it this way, clear. So, let us see that now. So, students, the parameter that affects the change in a particular output value, we can understand that by using the concept called slope. So, this is something which you would have heard, right. So, to understand slope, let us start with a very simple example. Let us understand straight line. So, a graph which looks like a straight line. So, if I plot the graph of y versus x input output, right. So, if that graph is a straight line, so let us take some graph. So, let me consider a graph which is like this, and for just understanding it easily, I will take the value of this the angle there to be 45 degrees, clear. I hope you all know how to write the equation of this line, right. By looking at the graph, will you be able to write the function which is going to give you a graph like that? So, even if not, I'll just give you a brief idea. So, we know that the basic form of a straight line is y is equal to mx plus c, where m is the slope and c is the y-intercept, right. So, for now we will just use this particular form of a straight line. There are other forms also in which you can write the equation of a straight line. So, you can have this, you can write a equation in this manner called point slope form. So, you can write it as y minus y1 is equal to m into x minus x1. So, to be able to write this, you need to know the slope and one point through which the line passes, one point on the line. To be able to write this, you need to know the slope and the y-intercept, clear. So, y-intercept means what? It is the value of y where the straight line cuts the y axis, clear. So, in this case, let us consider that this value here is some 2. Now, I guess you can easily write the equation of this line, correct. So, if I directly use this, I know the slope by looking at the value of theta. I'll tell you in a while why this slope is equal to, or how is it related with theta. For now, just let us directly write the equation of this line. So, the equation of this line would be, slope is basically the tangent of the angle made with x axis, clear. So, if the angle made is 45 degrees, then the tan of that angle is what we call as slope, and I will tell you why in a while. So, tan 45 is 1 into x plus y intercept is 2, right. So, I have y is equal to x plus 2. So, that is the graph which we have plotted. Now, as I told you, we define slope as tan of tangent of or tan of angle made with positive x axis. So, that is how we define slope of any straight line, clear. Now, one important thing which you will have to observe in this particular scenario is that if I take the angle that this makes at this value, you can easily calculate what that value is also. Where does the value of y become 0? Y will be 0 at x is equal to minus 2, right. So, at x is equal to minus 2, correct. Now, this is 0. Let us take few more values. Let us take x is equal to 2 here, and x is equal to 4, x is equal to 6. So, let us just take some values and see the corresponding outputs. So, if I take the output that I get here, how much would that be? So, at 0 we get 2, when I substitute 2 I get 4, correct. When I substitute 4, I need longer graph, so I will extend this. So, I get 8 and so on, right. So, this is the basic idea. Now, when you look at this graph, now let us talk about how the change is happening in this graph, how the output is changing when compared with the input due to changes in input. So, when I change the input from 0 to 2 and then from 2 to 4, how is the output changing? So, let us observe that. See, when the input is 0, the output I got is 2, correct. You can understand from the function itself. And when I changed my input value from 0 to 2, from 0 to 2, my output has changed from 2 to 4. Similarly, when I changed my input from 2 to 4, my output changed from 4 to 8. 8? No, it is not 8. When I substitute 4, I will be getting 6, correct. Okay. So, that is the idea. Now, to understand the change better, if I draw a horizontal line here and another horizontal line here like we have done in the earlier scenario. Now, observe closely the two triangles which are formed. Can I say this length is the change in x? I will represent that as delta x, clear, and this length here represents the change in y. Let me call it as delta y, right. And similarly, this length is the change in x and this length is the change in y. Now, observe what is happening here and what is happening here. So, when I changed my input by 2, my output is also changing by 2 from 2 to 4, clear. Now, when I changed my input from 2 to 4, once again my output is changing from this value which is 4 to this value which is 6. It is again changing by 2, correct. So, what I can say is, for a particular change, in this case I am changing input by 2, even here I am changing my input by 2. In both the cases my change in output is 2 itself. So, which means in this particular case, in the case of a linear graph, so a straight line is basically called as a linear variation, right. So, I will write it down here. So, it is also called as a linear variation, right, linear variation between x and y. Okay. So, whenever we have a linear variation between y the output and x the input, we can say that the change that occurs in the output will be same for changes at any value of input. So, once again I am repeating it. So, whether you are changing the value from 0 to 2 or 2 to 4, you can see that the change in output is the same. The magnitude of that change in output is the same. So, can I write in the case of a linear curve, the change in output, is same for a particular change in input, at any value of input, So, that is the basic idea of a linear graph, clear. So, whenever we have a linear graph, what it tells us is that the change is the same everywhere. So, as long as you are making same amount of change in the input, the amount of change you get in the output is always the same, at every value of input. So, whether you are changing from -2 to 0 or 0 to 2 or 2 to 4 or 4 to 6, whatever. So, as long as the magnitude of change in the input is the same, the change in output will also be the same, irrespective of from where to where you are changing the input, clear. So, that is the basic concept of a linear variation. So, whenever we have a straight line, so that is the idea which we have to get. So, from all this observation, what we can say is that change is same everywhere, for a given value of change in input, because the slope is same, Now, you can ask me, how do I know that? How did you relate change happening with the slope? I will just give you an idea. So, for example, in the earlier case which I have considered, the parabola y is equal to x square case. So, we have observed that for the same change, for example, let us say whatever is the change I have brought here, if I make the same amount of change once again, so this time I would observe a larger change in output, clear. So, if you look at the two triangles which are formed here, so this one, so this triangle and this triangle, if you look at these two triangles, so you can easily observe that I am making the same magnitude of change in both the cases, correct, same magnitude of change, but the change in output is becoming greater, and the reason for that is because this curve is more steeper. So, when compared to the curve here, so the way the curve is here the curve is more steeper. So, what is deciding the pace at which the output is changing, how fast an output changes, depends on how steep a curve is, clear. So, I will write it down here, steeper the curve, faster will be the change in output, clear. So, that is the basic idea. You can also understand it this way. If you look at the angle that is formed over here, so we can say that when compared with the angle here, we can say that the angle here is greater, clear. So, students, to understand the idea of change better, I will just draw a diagram, please observe closely. So, here the lines, the vertical lines I am drawing are equally spaced, the space between the lines is same, clear. So, let us consider that all these lines are equally spaced, clear. So, now I am just going to draw few straight lines and just observe them carefully. So, look at this straight line, right, and look at this straight line, and look at this straight line, and look at this straight line. So, I have drawn 4 straight lines here, right. I will name them 1, 2, 3 and 4. Now, you know that if I just plot an axis here x and y, so can I consider that the width between the lines as the change in input and the height of each line, not the vertical height of each line as the change in output, clear. What I am trying to say is, for example, if I consider this line 2, so for this line 2, so this horizontal length will represent the change in input and the vertical length represents the change in output. Now, you observe closely and tell me, in all these cases the change in input is the same, correct. Now, which of these 4 lines, in which of these 4 cases is the output changing by a large value, or in which case is the change in output greater? You can easily say that in whichever case the vertical distance is greater is the case where it is highest, or it is of highest value, clear. So, and in this case of 4, you can see that there is no change in output at all, right, and so there is no change in this case, no change, right. So, from this we can basically understand that the change and the slope are basically easily related with each other, and we define it like this. We know that slope is defined as tan theta, and tan theta is nothing but, how do we define tan theta? So, theta is the angle made with the x axis, positive x axis, as you see here, right. So, this is basically opposite is this or this. We know that the vertical distance represents the change in output. So, I will write it as delta y, and the horizontal distance represents the change in input, right. So, which is delta x. So, that is how we define the slope of a straight line, clear. So, slope is basically delta y by delta x, and that is how we are getting the value of tan theta, right. So, that is why I have directly used tan theta here earlier. So, this is the basic idea. So, by looking at slope, we can understand how fast something is changing, clear, some output is changing. So, as I keep changing the input values, so how fast an output is changing can be understood by looking at the magnitude of slope, right. So, in this particular case, if you see, this line is always making the same angle with the x axis. So, whether it is at at minus 2 or 0 or 2, wherever you see, at 0 it is making 45 degrees, here it is making 45 degrees, here it is making 45 degrees. So, everywhere it is making 45 degrees, correct. So, that which means the slope of that is constant. So, that is what I have written earlier. So, if slope is constant, it means that the change is happening in the same manner at every position, clear. So, that is the idea. So, students, let us now understand how change occurs in a different scenario, right, unlike a straight line. So, this time let us consider a parabola, right. So, a parabola like this. So, let us consider that this is the graph drawn for y is equal to some x square kind of graph, clear. So, you may ask, where do I come across graphs like that? So, a very simple example would be the case where, let us say, you go on to the top of a tower, a long building, and let us say you drop an object. So, if an object is dropped from the top, so I think some of you would have known that from the equations which we use in kinematics for a body which is starting from rest. So, considering that u is equal to 0, so the acceleration due to gravity pulls the body in the downward direction, and we can say that the distance covered by the body, if I represent it with s, so if I represent that with s, So, S will be equal to, the general expression is ut plus half at square, right. So, ut plus half at square. So, in this case u is 0 and we can consider a is equal to g. So, we can say that S is equal to half gt square. So, g value is approximately 9.8, right. So, if I substitute, this becomes 4.9. So, let us understand that we will approximate that and we will consider it as 5t square, right, 5t square. Okay, let us say that the graph which I have drawn here is the same graph, because it is in the same form of that, right. So, S is equal to 5t square, y is equal to x square. So, they are in the same form. So, this is how the graph of this looks like, which means if I am plotting S on y axis, which means S is our output, right, and t on the x axis, t is the input, which means for different values of times I am looking at how much distance the body has covered. Okay. Now, let us try to analyze this graph. So, this is the graph between S and t, and we know the expression for this, S is equal to 5t square. Okay. Like in the earlier case, let us see what happens at t is equal to 1, t is equal to 2, t is equal to 3. So, let us do the analysis for these 3 times. So, this is t equal to 0, 1, 2, 3. Okay. So, when I substitute the values, so I am taking equal intervals so that we can compare what is happening with the output, right. Okay. So, when I substitute S is equal to 1, sorry, t is equal to 1, I get S is equal to 5. So, this value here would be 5, correct. So, similarly, when I substitute t is equal to 2, 2 square is 4, 4 into 5 is 20. So, I get 20 here, and if I substitute 3, 3 square is 9, 9 into 5 is 45. So, I get 45 here. So, 45. Okay. So, fine. So, now using the same idea, you can easily get the idea that by looking at the graph itself, for equal changes in time, I am getting unequal changes in distance covered. So, in the first 1 second duration, how much distance is it covering? From 0 to 1, it is covering 5 meters, right. From 1 to 2, even though the duration is the same, here the duration from 0 to 1 is 1 second, from 1 second to 2 seconds also the time interval is 1 second. But look at the distance covered by the body, the distance covered this time is from 5 to 20, which means this is 15 meters. So, 15 meters, correct. And if you look at the next 1 second, it is travelling even more, it is travelling even more. How much is that? 45 minus 20, which is 25 meters, right. So, you can see that the body is travelling more and more distances in equal intervals of time, clear. And that is the reason why the graph, the slope of the graph is increasing. So, here if you see, the graph is almost horizontal, right, and as time increases, you can see that the slope of the graph is continuously increasing. It means that by looking at this graph, I can say that the distance covered by the body, the distance covered by the body is changing faster at higher values of time. Did you understand what I have written? At higher values of time. So, if I ask you, is the distance covered changing faster here or here? Where would you say? Here, right? So, at higher times, the distance covered is changing at a faster pace, clear? So, that is what I have written there. Okay. So, now from this, let us try to understand the concept of average speed. And the first thing which I asked you when I started, I have asked you about what instantaneous speed is, correct. So, let us try to understand what instantaneous speed is. For example, after dropping this ball from there, let us say the ball has travelled, let us say this is at t is equal to 0, the ball is here, at t is equal to 1, the ball is here, and at t is equal to 2, we know that the distance covered should be greater than the distance covered here, correct. So, I am drawing it down, right. So, t is equal to 2 and it should travel even further distance at t is equal to by t is equal to 3. So, we know that we have just seen from the graph that this is 5, this is 15 meters, everything is in meters, and this length here is 25. So, we have seen that. Okay, now, if I ask you what is the average speed? See, remember that average speed, the definition for average speed is something like this. Whatever you have been learning as speed till now is actually the definition for average speed, which is distance divided by time interval. So, average speed, distance travelled by time interval. So, in this particular scenario, if I ask you what is the average speed of that particle during the first 3 seconds, in the first 3 seconds, how much is the average speed? So, what will you do? It has travelled 5 plus 15 plus 25, which is 45, right, in a time of 3 seconds. So, what will you do? 45 by 3. So, when I substitute the value, so in 3 seconds, so I would be getting 45 by 3, that is equal to 15 meter per second. Okay. Now, I have known the average speed. Tell me, does it give me anything, any idea about what the speed of the particle or the object is here? If I am asking you with what speed is it travelling here, is that going to help me? Is that going to give us any information about how much speed the particle is going to have here? No, right? So, that is just the average speed. I will tell you what average speed means later, clear? How to understand average speed, we will have to discuss it separately. So, we will understand that later, but for now tell me, is that 15 going to give me any idea about the speed of the particle here? No, right, because the particle is starting with a velocity of 0 and the particle's speed is going to continuously increase, right, and we have understood that throughout this motion on an average its speed is 15 meter per second. That is what the formula has given us. But if I have to find how much is the speed here, how much is the speed here, so how do I find that, right? So, let us consider a scenario. So, please observe carefully, this analysis is very important. So, let us consider a scenario where there are a group of, let us say, some 10 students, right, and I have given them a work, and the work is to calculate the speed at t is equal to 2. So, at this point, so they can use any method, so they should find out the speed at t is equal to 2. So, let us say the first student, he has done this. So, first student has thought of it this way. So, I do not have a formula for finding speed at 2, but what I am going to do is, I will find the speed between 2 and 3, I mean the speed, the average speed which I got, I will find that between 2 and 3 and see what the value is, clear. So, he thought of calculating the speed, average speed of the body between 2 seconds and 3 seconds, right. So, let us write that here. So, he is doing for 2 to 3 seconds. So, when he has done for 2 to 3 seconds, the average speed expression is distance travelled by time interval. So, what I am going to do here is to represent the distance travelled between 2 and 3 seconds, can I write the distance travelled in this interval is nothing but distance travelled in the whole 3 seconds minus distance travelled in the 2 seconds, clear. So, the total distance travelled in 3 minus distance travelled in 2 will be distance travelled in the 2 to 3 seconds interval, right. So, I can write this as S3 minus S2, correct. So, which means this represents the distance travelled in 3 seconds, this represents the distance travelled in 2 seconds. So, the difference between those two is the distance travelled between second and third second, which is 25 in this particular case, right. So, divided by let me write it as T3 minus T2, right. So, when I substitute the values, I would be getting 45 minus 20. So, I will write it down 45 minus 20 divided by 1, correct. So, in this particular scenario I would be getting 45 minus 20 is 25 by 1. So, I would get 25 meter per second. So, that will be the average speed when I calculate between 2 and 3, correct. Okay. So, now the second student, he thought, so why do I have to calculate between 2 and 3? See, I know that the graph will give me values at any time. So, what he did was, he did this. He thought of calculating the average speed between 2 and 2.5 seconds, right. So, you know how to find this. I can write this as S at 2.5 minus S in 2 seconds divided by this, correct, right. So, S in 2.5 seconds. How do I find S in 2.5 seconds? How much distance will the body cover in 2.5 seconds? I already have the expression to calculate that. So, let me quickly substitute that. I will be getting S is equal to 5 into 2.5 square. 2.5 square is how much? 6.25. So, this into 6.25. So, that would be 31.25, right. So, 31.25 minus this S2 is 20 itself. So, 20 divided by 2.5 minus 2 is 0.5. Okay, calculating this. So, this will be 11.25 by 1 by 2 is 11.25 into 2, correct. So, 11.25 into 2 is 22.5 meter per second. So, he got a different value. So, student 1 got a different value, student 2 got a different value. Okay, fine. Let us continue this process. So, third student. So, what he did was, he has seen both the results. So, he thought, I need to find the speed here. So, what the first student has done is, he has taken a long interval of 1 second. The second student has taken 0.5 second interval. So, third student thought, I will take even smaller interval. I will take an interval which is very close to 2, a very small interval. And what he did was, he found between 2 to 2.1. So, he found the speed, the average speed basically, in the interval of only 0.1 seconds, clear. So, which means he is calculating S in 2.1 seconds minus S in 2 seconds by 2.1 minus 2, which is 0.1. So, when you substitute the value, what is S in 2.1? I will once again substitute the same thing. So, I would be getting some 2.1 whole square, right. So, when you calculate that, you would be getting 441, this is 441 into 5, 441 into 5, 441 into 5 is 5, 20, 0, 2, 22. So, 22.05, right. So, 22.05 minus 20 divided by 0.1. Now, how much is this? So, this would be 2.05 by 0.1. When I solve that, I would get 20.5 meter per second. Okay. So, he observed, he got a different value once again. Now, the fourth student, he thought even better. Okay, the value is decreasing, okay, fine. So, everyone is getting a better value than the earlier person, because each one is taking a smaller interval. So, he thinks, let me take even smaller interval. So, what he does was, the fourth student, so he takes the time interval between 2 to 2.01, a very small interval of only 0.01 seconds, correct. And he does the same calculation. Distance travelled in 2.01 seconds, the similar analysis, and when he found, the value comes out to be 20.05 meter per second, which is even smaller than this, correct, right. Now, similarly, if the fifth student had tried this, he made even smaller, 2 to 2.001 seconds, and if he did the same analysis, for him the value comes out to be 20.005 meter per second. Now, let me stop here. So, I can't keep doing for all the 10 students. I hope you can observe a pattern here, right. Okay. So, what the pattern here is that as I am decreasing the time interval to a smaller time interval, which means instead of calculating the speed, average value of speed between 2 and 3. So, we have decreased the time interval, we have decreased it even further, further. So, as I approach smaller and smaller and smaller and smaller values, can I say that the final result which I am going to get will be the average speed for a very small interval of time, correct. So, let us say I am continuing this many times, not calculating, as a thought. So, just give it a thought of what is happening. So, as I continue this process, where would this lead me to is what we need to understand. I am repeating once again. So, this is a very important thing. The reason is I am not doing the calculation here, I am just looking at the values which I am getting and I am looking to where is it approaching to, correct. So, if I am making this smaller and smaller and smaller, very small, let us say I am calculating between 2 to 2.00000000. You cannot even think how many zeros I am going to write here, infinite number of zeros, clear, and some 1. So, if I calculate between this, obviously we can't calculate, but we can think, right, we can think about what can happen. We all have logic, we can apply a logic, we can look at patterns, right. So, now think about what is happening, what is going to happen if I calculate or do the same analysis between these two instants in that very small interval of time. So, what happens is that this value will also be decreasing continuously, but it would be approaching one particular value which is 20 meter per second. Clear, you can see from 25 we have started, it is becoming smaller. So, initially 2.5 is the decrease, then 2 is the decrease, correct. Then how much is the decrease? Oh, not this here, right. So, from here we have 0.45 as the decrease, from here to here we have even smaller decrease. So, the velocity is, the average speed is continuously decreasing, and eventually you will observe that it will tend to 20 meter per second. Now, once again I am repeating, the value is not becoming 20 meter per second, it is approaching 20 meter per second. That is a very important idea here. Now, why? Now, what does that 20 meter per second tell us? Clear? So, let us see that now. So, let me erase this. So, now what that 20 meter per second tells us is that if this interval is very small, which means here the value of delta t, so value of delta t is very, so many very small. In such a scenario, I am getting the value to be closer and closer to 20 meter per second. Now, let us see what this means. What does that mean? It means that I am finding the average speed between the instant of t is equal to 2 and an instant which is very close to it, clear. So close that can I assume in that very small interval there will not be any change, correct. See, if let us say I am in a car, correct. If I am in a car and let us say I am pressing the accelerator, clear. If I am pressing the accelerator, speed increases, but for the speed to change from let us say 10 meter per second to 15 meter per second, I need a time duration, right. So, I need to press that accelerator for a while. Just by hitting the accelerator and releasing it, will my speed suddenly change from 10 to 15? No, correct. So, I need some time for the speed to change, right. So, in this particular case, the time interval which I have taken is very small. So, can I say in that small interval of time, the speed does not change at all? Can I assume that? Can I safely assume that? So, this basically gives us an idea that in, let me write that, in such a small interval, speed does not change, So, the average speed which we calculated we calculated can be considered as the speed at that instant, or you can say in that small interval, in that very small interval. Clear? So that is the basic idea. So remember that I have not calculated anything here. I am just using my thought process to understand this pattern, right? So if I am making this very small, I know that in that small duration speed won't change. So whatever average speed I am getting, that will be the actual speed also. So students, let us now understand the earlier idea by using a graph. So whatever the students who have done those analysis, those calculations, if we try to understand that by the graph. So what they have done was, we know that the first student has calculated this value, right? We have just seen. So S3 basically means this. So this S3, this is S2, correct? And he divided that with 3 minus 2, which means we know that 3 minus 2 is this length. S3 minus S2 is this length. Now what is this length by this length? You already know that, we have seen earlier. So this length by this length is basically the line, sorry, the slope of line joining this point with this point, correct? So the slope of line joining those 2 points is what the student 1 has calculated. So let us draw that line. Okay, so this is what is the slope which student 1 has calculated. Now let us talk about student 2. Student 2 has done the analysis from 2 to 2.5. So let us say 2.5 is here, and from here if I draw a vertical line, so yeah, so this is 2.5. So what he calculated was this length, because S2.5 minus S2 is this length, divided by 2.5 minus 2 is this length. So he has calculated this by this, and you know that that is nothing but the slope of line joining these 2 points, correct? Right? So if I draw that line as well, so that would be something like this. So observe closely, this is our graph. So I will draw it darker. So this curve here is our graph, and the straight lines are the lines for which they have calculated the slopes, right? Okay. So student 2 has calculated the slope of this line. So this is the point, this is the other point which student 1 has used, this is the point which student 2 has used. Now let us look at student 3. So what is student 3 doing? Student 3 is taking the time interval as 2.1, 2.1 is here, very close, which means just by using the same idea, can I say that he has calculated the slope of line passing through this point and this point, correct? Which means student 3 has plotted, he has taken a line like this and he has calculated the slope of that line. Now I won't be drawing any other lines now, just try to think about what happens, the same thought experiment which we have done earlier, so on. If I take it further continuously, what is going to happen? What is the 10th student going to do? What is the, if I do it for many number of times, what is the last person going to do? Can I say that keeping this point fixed, the first person is using this point, the second person is using this point, third person is using this point, correct? And let us say the 10th student will use a point which is very close to this point, and if I consider that the last person which we can take, that person will take the point so close from this point that both will be upon each other itself, they will be overlapping each other, they are so close, clear? So the 2 points are very close that the last person who has considered, who would be in this particular series, would be basically drawing a line which is passing through this single point itself, clear? He will draw a line like this, clear? He will draw a line like this. So, this is what is the line drawn by the last person, and he will calculate the slope of that last line. Clear? So, the line which is passing through that single point alone. Did you understand why I am saying single point there? Because everyone is taking 2 points, but one point we have fixed here. The second point is initially here for the first one, first student. For the second student it is here, third student it is here, fourth even closer, even closer, even closer, and as I go closer and closer and closer, we can say that it becomes so close that the 2 points overlap with each other, and there will be a line which is passing through that last that single point, correct. So, what this basically means is that I think you must have known this idea of secant and tangent, right. Secant is basically a line which cuts the curve at 2 different points. So, it cuts the curve at 2 different points. And tangent is something which touches the curve, it touches the curve at a single point, at a single point. Okay, fine. Now, let us think back about what we have done earlier. So, in the earlier analysis, we understood that all these persons, this fellow is calculating the average velocity from 2 to 3, correct. This fellow is calculating the average velocity between 2 to 2.5, average speed or average velocity, and this fellow is calculating average velocity between 2 to 2.1. So, similarly, if I go to the last person, so what is the last person doing? So, last person is also calculating the average velocity between 2 and 2 point, I have told you earlier, infinite number of zeros, as many zeros as you can imagine, into, I mean I should not directly write, so on 1, right. So, the time interval is so small that we have considered that this average value is nothing but instantaneous value. It is not average speed, it is instantaneous speed itself, instantaneous speed, right. So, that is the basic idea. So, now observe carefully. So, from here we have seen that the first person is calculating the tangent, I mean the slope of this line, second person is calculating the slope of this line, and the last person is calculating the slope of this line, which we called as the tangent, which means from all this idea we can say that this is the slope of a secant, right. It is the slope of a secant. Average value between 2 and 3 is the slope of a secant which is cutting at 2 and 3, t is equal to 2 and 3, right. Similarly, this is also a secant, right. This is also a secant, I mean slope of secant. So, if you observe, each one of these students is actually calculating the slope of a secant, whereas this last person, a hypothetical last person who actually does not exist, as I told you, no one is making this calculation, right. There is no person who can make this calculation, it is just our imagination, right, it is just our thought. So, this last person, what is he doing? He is basically calculating the slope of a line passing through 2 points, correct. Those 2 points are so close that the line passing through those 2 points is nothing but line passing through that single point itself. The points are very close that they are actually the same point, and the line which is passing through that single point is what we called as, let me remove this 3, it is little bit confusing here. So, just look at this case and this case, clear. So, this is a secant, this is a secant, this becomes a tangent, and as I told you, there is no one making this calculation except our thought, clear. So, that is the idea. So, this is basically the tangent. So, from this we can understand that if I need to find the speed of the particle at a given instant of time, so let us say at t is equal to 2 seconds. So, at t is equal to 2 seconds, if I have to find the speed of a particle, all I need to do is just draw a tangent to the curve at that point and take the slope of that. So, whatever we have done till now is basically the reason why we are using this result, and the result is that the result that we get from all this analysis, the result is that the instantaneous speed at a given instant is the slope of tangent drawn to the S versus T curve. Clear? So, that is the basic idea. So, this whole analysis is basically giving us that particular final conclusion. So, what we have concluded is that all of these lines, the slope of all of these lines are giving me the average value of speeds in that interval, whereas the final tangent which is drawn at 2. So, this final tangent which is drawn at this point. So, let me remove these lines as well. So, this is the final tangent which we have drawn like this. So, this is the tangent, although it is little bit curved, just try to understand. So, this is the tangent. So, 1, 2, all these are secants, right, they are cutting at 2 different points. So, they are giving average value of speeds between those instants, this first one between 2 and 3, second one between 2 and 5, whereas this last imaginary person who calculated this is calculating the slope of tangent, and that is what we understand as instantaneous speed. Clear? So, this is the final result that we understand. So, please keep this in mind. So, whenever we need to find speed, and if we know how distance is varying with time, so this is distance covered versus time, all you need to do is look at the slope of tangent. So, remember, slope of secant is the average speed, slope of tangent is the instantaneous speed, and you know that slope will be greater if angle is greater, right, which means speed will be greater if angle made by the tangent is greater. Students, let us see this example. So, here they have given us a graph between distance covered by the particle and the time. Clear? And you can see that the variation is something like this. So, they have given us three instants t1, t2 and t3. So, if speed of the particle at times t1, t2 and t3 is v1, v2 and v3 respectively, arrange them in the increasing order, right. We need to arrange the speeds at this time, at this time and at this time. So, these three we need to increase them in increasing order, right. So, I have told we have just discussed that. So, speed is nothing but the slope of tangent right, slope of tangent drawn to an S versus T curve, distance versus time curve, correct. That is what we have seen. So, let us draw the tangent. So, at this point if I draw the tangent, so the slope of that tangent is going to give me the instantaneous speed at that point, right. We have just discussed why we call it as instantaneous speed. So, similarly, so if I draw a tangent here, so the tangent would be something like this, and if I draw a tangent here, the tangent would be something like this. So, we need to just arrange the slopes, arrange the speeds in increasing order. So, speed is directly proportional to the slope, or slope is what we call as speed. So, in which of these three cases, 1, 2, 3, is the speed or the slope greater? You can easily see that here the line is like this. When compared to this, here it is more steeper means more slope means more speed. So, this is where the speed is the greatest. So, we can say that V2 is the greatest, then followed by this is making some angle, whereas this is making 0 angle, right. So, from this can I say that this is where the slope is 0, because slope is nothing but tan theta. So, tan theta. So, theta is 0, which means slope is also 0 at 3. So, this is at T3. So, which means the speed at that instant will also be minimum. So, V3 is the least followed by V1. So, this would be the answer for this question. So, students, let us summarize the concepts once what we have discussed even finally. So, speed. So, how do we understand speed? So, speed is basically the rate at which distance covered by the body changes with time, correct. So, if I am covering my distance faster, it means my speed is more. So, if my distance is changing slowly, I am moving slowly, my speed is lesser. So, that is what this means. So, that is the basic idea of speed, right. And then what we have done is, if the time interval taken is very small, we also call that very small interval as infinitesimally small. So, this is a term which we will be using for that. So, if the time interval is infinitesimally small, which means close to 0, then we can consider that whatever is the average speed we calculated in that interval is also the instantaneous speed in that interval, and that interval is so small that we can take it as an instant. Instant means single moment, clear. Now, if the time interval decreases as it becomes smaller and smaller and smaller, it becomes infinitesimally small, then the secant which we are drawing in that curve will it will become closer and closer to tangent. So, that is why we used the idea that instantaneous speed is nothing but the slope of tangent of S versus T curve, clear. So, students, that is the idea about speed or instantaneous speed. So, what we understood is basically based on the idea that speed is the rate of change of distance, correct. So, in the same manner, so tomorrow in the next class we will discuss about rate of change of any function, clear, not just distance, what is the rate of change of any function, clear. So, that is the idea.